Okay, this is 1.4, which is all about angles. So first we need to review how we name an angle. There's 3 different ways to name an angle. You can use just one letter, which would be the vertex, or you can use 3 letters, but you would always put the vertex in the center. Or if it has it, you can use just a number to name it, and you always put the angle sign in front. So we're using 2 different geometry statements today. The first one is angle addition postulate, which is a lot like segment addition postulate. You just add the 2 angles together to equal the whole thing. So it's basically saying like whatever this angle is plus whatever this angle is equals the entire thing. These little m's out here are important, and we'll talk about that on the next slide. The other one we're going to use is definition of a bisector, which we've already covered. You just have to remember that bisect means it cuts it in half. Okay, so we have shapes and we have numbers. So something like a triangle is a shape and 3 is a number. But in here we have more things that are shapes and numbers that you're not used to seeing. So this is a shape. It represents a segment. And this is a number that represents the measure of a segment. So an angle would be something like ABC, and for the number it would be the measure of angle ABC. Now shapes are congruent where numbers are equal. You cannot add numbers together, and you cannot add shapes together, and you can add numbers together. Okay, so an acute angle is somewhere between 2 numbers. That would be 0 and 90. It does not include 0 and it does not include 90. And this is not important. Then we have a right angle, which is exactly 90. An obtuse angle is between 90 and 180. Doesn't include 90 and it doesn't include 180. And then for a straight angle, it's exactly 180. Okay, so for this we're going to use angle addition postulate. So we're given that the entire thing is 95 degrees. So this whole thing is 95. So we know that 6x plus 12x plus 5 equals 95. So we can combine our like terms and get 18x plus 5 equals 95. Now when we move the 5 to this side, we subtract it, so we get 18x equals 90. And then divide by 18 and you get x equals 5. Now you don't have to plug it back in because it just tells you to find x. So pause the video and see if you can do this one on your own. I'm sorry, that's not right. Plus 2x minus 6 equals 135. So 5x minus 5 equals 135. And then 5x, when you add the 5, it equals 140. And then x equals 28. Now it says to find the measure of angle RST, so that's this one right here. So you have to do 2 times 28 minus 6. So 2 times 28 is 56, minus 6 is 50. So then we have angle bisectors, which bisect means it just cuts it in half. So these are congruent angles. So 4x should equal 3x plus 6. So if I subtract 3x from both sides, I get x equals 6. So see if you can do this one by yourself. Pause it. Should get 12 for x, and then when you plug that back into DBC, you get 4 times 12 plus 1, which is 49. Okay, so this proof is going to have both angle bisectors and angle addition postulate. We're going to start with a bisector because it says it bisects it. So M angle ABD equals the measure of angle BDC. And that is definition of a bisector. And the second step is always going to be substitution. Then I'd subtract the 4x from both sides, so I get 4x over here. That was subtraction. Then add the 16, so I get 4x equals 36, and that's addition. Then I divide both sides by 4, and I get x equals 9. Now this part's a little bit trickier. Normally you could say something like ABD equals this, and that's given, and then just plug it in, but it's asking for the whole thing. And we don't have a measure for the whole thing, so we have to add these two together. So it's kind of a long step. You add ABD plus the measure of angle DBC to get the measure of angle ABC. And the thing that says you can add the two smaller ones together is angle addition postulate. Then you plug in what you know as a 20. That's substitution. Sorry, I'm trying to fit all this in here. Got one M. Okay, so then we get 112 for the measure of angle ABC, and that's arithmetic. Oh wait, whoa, sorry. I forgot a step. First I have to actually plug in the 9 for x. And then I can get 112. That's substitution again. Then we get 112 for the measure of angle ABC. That's arithmetic. Then we got to flip it around, and you get the measure of angle ABC equals 112, and that is symmetric property.